it wouldn't come off smoothly as it should. So we tried standoffs of two different sizes, and it just and so what it pretty much does is turns onto where the block is, and as we're going up, it just picks it up. So let's see right here. This is an example. So I could just take it. I don't know why it's taking so long to load. All right, there. So you could see as it comes out, and now the block's gonna come up, and it just picks it up, and then we place it, and we got like an extra 10 points off of that. So yeah, just take points wherever you could get. That was like one of those things that most of the stuff you're supposed to take a long time to design, but that was just one of those things that was like a very simple solution that worked great for extra points. So we just used that. We just implemented it in that way. So, and another problem we had was as we were going up, we didn't want, and wires would always get tangled up. So our final design and how we implemented it was we soldered telephone cables to be able to connect to servo wires. So we got the telephone cables going up and down easily without getting tangled up and getting caught up in everything. And but like the most one of the most well thought out parts of a robot, and it's pretty simple, was our ramp. So this was 3D printed from scratch and was designed from scratch. So at first with our prototype, we started off with a cardboard design with some polycarbonate, except that wouldn't smoothly pick it up, and it would always get caught up in something. So we needed something that was rigid and strong that would smoothly just slide up. So this would just, so as we were just moving towards the ball, towards the block, it would just smoothly pick it up like it was nothing. So we designed on that for like a good like 5 hours. This was our original design, if you could. Oh, yeah, this was like our prototype, and it worked somewhat, except we implemented this into this, and it worked great. Yeah. So let's see what else is there. Oh yeah, the electronics. Give me a second. Actually, yeah, let's show you the outtake. So as I was saying about the grabber, aka the outtake, so this is the original picture that me and my robotics team and I drew out. So we had a basic idea of it. We had the 4-bar. This is called a 4-bar system, by the way. So pretty much as it's moving in this direction, it stays at the same height, instead of where if you had a normal system, it would like slant the grabber, but it always stays at the same height. So we decided to go with this system. We had a pretty basic idea of it before we built it. So there's 3 servos in the system. One servo that brings it out, one servo that turns it, and one servo that grabs the block. So this was the version 1. This was the version 1 that I designed. So we tried to go with some adhesive foam on it with rubber bands to keep it. This is just a prototype, and it didn't really work out because it would constantly slip out. So that's where the anti-slip material came in. So the anti-slip material just kept it in place pretty much. So you see this engineering notebook, we just went through everything, our designs, our flaws that we went through throughout the seasons. Everything, we always started off with a prototype. For example, with the capstone, we started off with a cardboard design, eventually 3D printed it. With this, we had many different implements of it. And we had many different implements of our stringing. I can send you guys a link to this if you want, and you guys can go through all of it. It's pretty interesting. It's like many pages long. It's like it was a lot of work to put it. We put a lot of work into it. But let's see. Is there anything that you guys want to know about our robot and how we did it in the design process?
Yes, I have a question. So we just leave the robot like that, or would you put something on it like to cover up all the wires, gears, and everything else?
Okay, so to cover up the wires, okay, there's not a picture of it. So the basic implement of our chassis was just, let's see, let me go back to it. Okay, so this is the basic, this was just our basic chassis. So the way we covered up wires was, first, as I told you before, we used the telephone cables to like make sure things didn't get tangled. And second, we also, so we were thinking, so these are channels and they're open on the bottom. So a good way to do it was we put a bunch of, like for the motors and all the sensors, we channeled them through these bars, because under there's a lot of space. So all of our wiring was under the robot and it stayed really organized. Wait, was that your question?
Well, kind of. Like that's the interior, right? Like how does the exterior look like? Did you like eventually put something else on it for the exterior, or did it stay like that?
This is the basic robot to organize the wires and everything. As you can see, there's not many wires that you could see other than over here, here, because we put all of them in these wire sleeves in order to make sure they weren't organized, in order to make sure they stayed organized and didn't get tangled up. Except there were a few times this season during the games where we did have a few mess ups on the wiring, because sometimes this would get tangled up. This wire would often get tangled up onto here, so it would always mess up and it wouldn't be able to hold the block properly or fully outtake. And so, but eventually we figured out that we just put zip ties to keep it in place, and yeah, organized up everything basically.
Okay.
Any other questions? Like, is there anything about the robot design that you guys would like to know? And any questions of how we implemented everything?
How long did it take you to build a robot like that full, from beginning to end?
Okay, so it all came into pieces. So the season started in September. Our goal by December was to have this, and this done. And we basically had that done. So we set a goal for December by then, and we had it done. So pretty much to be able to stack by the first competition. So we had that done by then, and after that we had another month. So after that first competition, we had until in December, we had until like the end of January. So after that first competition, we decided to implement the back grabber for the foundation, to move the foundation. And then after that competition, we won in the finals. So we're like, okay, our robot's where it's supposed to be. So then we started working on this. So this was for the autonomous. So we had a great autonomous after that, where it could move one block to the other side, and we could also use the back grabber during autonomous to move the plate into the build zone. And finally, this was our last focus, the capstone, where we would get an extra 10 points just to have it come and lift up. Yeah, so
But
that
it took
was
around
so
a few
in
months.
what?
So it took around a few months?
Yeah, it took around a few months, except we did it in parts, pretty much. So it wasn't, so we could have done it faster, except we took things slow, took it in parts, and made sure everything was perfected before we moved on to the next.
Okay, thanks.
Pretty much. Yeah. Is that it? Any other questions? Yeah, I guess that should be it then, if there's no other questions. Yeah. Okay. Thank you all for joining today. Yeah, I guess that's it. See you guys. Bye. Thank you all for joining the class.
Is this the last meeting?
I'm not sure. Either I'll see how many people can join tomorrow. If there aren't many people, then yeah, this is going to be the last meeting.
Oh, okay.
Yeah. Okay. Thank you all for joining. Thank you. Have a great day.